So, we are going to finish this thing up. I just want to make sure that y'all are cool with these last ones, and then we can start poking at individual questions that you'll want. But I just want to breeze through these at least, just to kind of like, aha. I think that these are easy because there's an R here, and when you push this down, you're going to get a U sub thing. Very simple. Here, we're going to get like R cubed, but I'm not worried about polynomials. So, whatever. Right. Same thing here, U sub, because you already have the R. When you start talking with this guy, he'll be fine. Um, that that's actually out of order, right? Isn't that a little odd?
Yeah, well, it also has C over 5 up in the top.
That's what made me stop for a second. I was like, it's not supposed to be up there. But yeah, so that's fine though. You'll just get Z cubed, and it's whatever. I'm wanting to see. Okay, so here's the perfect example. Pause. Right. Cosine squared. There's no way to get around that. You need the formula for that. And I already warned you. Okay, good. So this is on the exam. Hey, look at that. You might not get it, but that's definitely a possibility. But the rest of it's not too bad. Just the cosine squared. Got to have a formula for it. This one, wouldn't I end up with a sine? Is it going to be cubed? Or you're already done? Oh, is it working though? Oh yeah. Go ahead, bro. Anthony's helping me with the math-based stuff. Oh, okay. No, you don't know.
Plus 3.
Oh, it will eventually. Yeah, if you write it all down and at the end, I'll give you a chart. And you go, okay, oh, you're happy so far. And it's actually flew in. You're able to do the math? Yeah, you will. You will see that soon. Okay, cool. Okay, thank you. You're doing great work. Okay, yes. Yeah, let's do it. I'm all about doing the math. And this one freaks me out a little bit because I think it might be a fourth power. But I did I say n power or did I say cube? I can't remember. Oh, I said cube? Okay. Give me a second. I need to get rid of this junk. Good. Okay, good. Okay, good. Yeah, let's do this one. I'm super happy for it. Again. Okay. I feel like it's hot today. So hot. Why is this not a temp? Okay, thank you. Okay, here we go. So yeah, triple integral. I'm just going to copy it down, and then I can full screen it. At least the directions are very straightforward. You know what I'm thinking? I'm thinking that there's a trick around this one where we don't have to do any math. Okay, so that's what we're doing. Okay, before I keep going, I want to point out the reasons why I'm thinking there's like tricks. So we got theta is 0 to 2 pi, and then I got phi is 0 to pi. And so right now I'm saying all the way around and then all the way from up, all the way down, like a full sphere. I'm saying full sphere, or rather all possible goes arounds. The only difference is that my radius is changing. It's not just 2, it's 2 sine. So I'm thinking that this sine of phi, it starts at 0 and then it balloons out. So I'm thinking it's going to end up looking like a torus, like a donut, essentially. And so I'm thinking find the volume of a donut, which we can with a formula. And you can write that down right now on your note card. But I'm not going to do that. I'm going to try to not cheat. But, I mean, you're kind of seeing that there's some commonalities here. This is that default for a spherical. Therefore, the density's 1. It's like not variable. Okay, so let's do some math. Cubed over 3. Am I right there? Yes, true. Okay, thanks. And then, I still have a sine phi in there. d phi d theta. And then I'm going to toss this guy in. And so I get 2 cubed is 8. So now I have 8/3 in the front. Double integral of basically sine cubed phi times sine phi. And that's where I'm nervous and I don't like this problem anymore. Am I correct so far? That's sad. So then I got sine to the 4th power. Darn. I was hoping it would be a cube, and then I wouldn't have lied to you. Where did I put that anyways? Did I put that in Blackboard?
Yes.
Oh, let me change it. Give me a second. Hold on. Where's my? Oh, I don't have Blackboard. I don't have Blackboard up right now. Okay, I'm just gonna pull up Blackboard. Okay with y'all? I don't want to be a liar, so I want to change it right now. Oh, but y'all heard the announcement, right? That I extended it for everybody until next Friday. Woo! I know. Is that a bad thing? You were prepared for the. But now I'm trying to give you more time. Okay, cool. It's just like you're still so mean, Chad. That would be that Monday, but I can maybe push it to the Wednesday. But yeah, you're right. It's coming down to the little end here. It is. So let me go back to my formulas and revise my formulas right in front of you. See, I had cubes. That's incorrect. I'm gonna put an n in there. Okay. Now I'm not lying anymore. Yay! And now I got to do it for the online class. Sorry. Say that again. Well, if you had a formula book, hidden. Didn't want it to be hidden. Okay. N and N. Now I feel like I did something right today. Okay. Good. Yeah. So we have 4th power. Let me do the formula for that. So sine to the n is not on that page. It's on this page. Here we go. So integral sine to the n power. I'm just going to use x in this particular case. It's like u. It's negative sine of n minus 1 cosine, x, cosine of x all over n plus n minus 1 over n integral of sine to the n minus 2x dx. Sorry, I didn't have enough room for dx. I'll just kind of do a little dx arrow there. So that's my formula. Essentially for this one, when I do my phi, I'm just going to say it's going to be negative sine cubed cosine all over 4 plus 3 over 4 integral of sine squared. Okay. This is really annoying. Go away. Okay. There we go. So we still have to do the sine squared. Yes, please. Oh, okay. Okay, then let me make it bigger like that. Yeah, I'm waiting. Yeah, I can wait and hang out. I do not mind waiting and hanging out. I got nothing else to do besides all that stuff for tomorrow. But for an hour, I'm here. Oh, okay. I'm excited for math day. Yeah. Right?
I'm stressed.
About math day? There's a lot going on. But once you're done with that linear chapter 7, then that's done.
Oh, and the exams are.
Well, yeah, but there's not like there's not like homeworks to do or anything. No more quizzes. It's just whenever you're ready, take the exam.
I got a copy.
I'm trying to make it positive thoughts. True, true. But you're not the one that's most behind in this class. So no, I'm sorry. I'm playing with you. Yeah, I'm sorry. I didn't want to call you out, bro. You were gone for a week.
I was gone for a week.
There you go. So
Trying to catch up.
you're fine. You're fine. Y'all are all doing great. In fact, I was redoing the grades in the My Math Lab grade book. Apparently, I had done it so the exams were not as weighty. So everyone has not just an A, but an A plus now. So everyone's grade went up. Yeah. Anyways. I mean, yeah. If you're missing a couple homeworks, I think you'll be fine. Cause yeah, it's great. Okay. Are you good with the formula?
Yeah.
Cool up to this point. Now, I got the sine squared formula. So I'm just gonna like keep going over here. So 8/3 integral. So this is still inside. I'm just trying to make sure I organize it correctly. So I'm gonna be a tiny bit careful here. And that's a cube. And then I have 3/4, and then this thing. Now the formula for sine squared, this is just literally a pop it in. It's going to be a 1/2 of the phi plus, or it's minus. Sine is a minus. This is why we write it down.
It's science pot. Oh, no, it's negative.
Yeah. This is why we write it down.
Yes.
Or we all get it wrong. One or the other. So that's the formula for the sine squared integral. And then I'm like done with that. And then all of this is still d theta, and I'm supposed to go from 0 to pi. Awesome. We're back on track. So if I plug in the pi, I'm going to get 0 out of this guy, which is kind of unfortunate because I spent so much time on him. So
Everything cancels out except for the
yeah, yeah. Wow. Okay. It makes you feel the futility. You know what I mean? It's just like futility. It's like you just put so much effort into it, and nah, none of that even mattered. And then there's no thetas, so then we just say the 2 pi slide. And so then I got 8/3, 3/4, 1/2.
Oh, sorry.
They're mushing together. I get you. And then 2 pi. So then these cancel. Those cancel. Those make a 2. So 2 pi squared. It seems so sad, but at the same time, I had the formulas. Good thing. Does the n formula work for a square? As in, if I had only this one formula and I had a 2 right here, would it still work? Because like 2 minus 1 is 1, so sine in this, and then I'd have a 1/2 sine of, or sine to the 0 is a 1. So that would be your theta, because that would be a 1, and your integral would be the theta. Yeah, okay. Yeah, so that formula works for squares too, just in case. A specific what? Oh, yeah, number 48 and number 50. Yeah, the ones in the formula book. I think Amanda kept the same numbers on her new one, so she has the most accurate one because there are a couple mistakes in this. So I'm pretty sure this one's fine, but just in case, Amanda has the best one. We're gonna test it anyways. So we're gonna call it 2 pi squared. Now again, this was a torus, like a donut without a hole in the middle. It kind of made a pinhole. There's a formula for something like that. I'm sure you could just go boop and be done. But anyways, cool now. Okay, it's good to do it. So here we would get cosine squared, but because there's a sine out here, it would just be a u sub. Not too worried. Again, we can come back to any of these if you want. The secant scares me. You want to do it?
Wouldn't that also just be U sub?
Probably. I don't know. What's the derivative of secant?
Secant tangent.
So see how that's not the same?
Actually, wait, no, that's integral of secant.
No, you're right.
Oh, I was
Derivative of secant is secant tangent, yeah. You're right. But I don't see that from this. Would you like me to try it? Do you want me to do it, yes or no?
Yes.
Okay. Good, yeah. That's what I do too. I'm seeing if I can like figure it out. But so I'm just writing it down so I can full screen here. I might have deleted this one just because I saw secant and got scared, but I can't guarantee that. That looks ugly. So I'd rather be on the safe side here. Okay. So when I integrate this, I get the cube over 3, and the 3's are going to cancel, so that just makes it pretty easy. I'm going to say 2 minus this. No. Be careful, Chad. Be careful. I'm saying it's 2 cubed minus secant cubed. No, stop. And then I still have that sign hanging on the outside. D phi, d theta. I skipped a step, I know, but so we have an 8. Of course I'm going to distribute. So basically I got 2 separate integrals now. I got 8 sine of phi, and then minus, I'm going to have secant cubed sine. This one's easy. I really want to make sure I'm doing this one right. So isn't secant technically like cosine in the bottom? So what I have is a cosine cubed, and then I have a sine. Oh, I put a theta by accident. I feel like I could. I feel like a U sub.
If you remove one of the cosines out, you can get tangent, and then the derivative of tangent is secant cubed, which we cancel out the other secants.
Secant, tangent, secant, tangent,
Exactly.
secant. Math. Right, so we have, if you rearrange it, we have a secant, a sine and a cosine, and then we have secant squared, and you're saying that I keep putting equals, is a tangent.
Right.
And then you are also saying that if I did this was u is tangent, then my du would be secant squared.
Yes.
And so therefore I would basically have double integral of u.
Right.
And then it's simple. And this was already simple. Is that true?
Yes.
Okay, I don't want to do it anymore.
Like I remember this one specifically now.
Good.
They wanted you to instead of doing the doing a tangent and a secant squared, they wanted you to take the derivative of secant and then cancel out stuff with a secant tangent rather than doing just a tangent and derivatives.
I need more coffee. So
So clarify, taking secant without any tangents involved and solve it that way, which is longer.
yeah, that's longer. Okay.
Yeah.
Blink, 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 blink. Exactly. Okay. That's a pretty nifty little thing to do there. There might be other ways that are easier, and I don't even know if I kept it because I got scared with the secant maybe. That's what I do. I get scared. Y'all okay? You good? Okay, you copy that down. I'll keep moving because I'm not really doing that problem. This one is a little different. See this 2 in the front here? That's not any harder to integrate, but you have to remember to do it. Like I guess you could say u sub, but really it's just divide by 2, right? Cosine cubed. So again, we had this is on there. This is on there for sure, because I specified the cube, didn't I, in my formulas? So there you go. Now you have a formula for that as well. But notice that it's all not numerics for my definite integral. That's nice. Are we okay with that? Yep. Yep, this is on there. I'm gonna have to blow it up though. So we got top, we got bottom. Triple integral, no problem. I think you're gonna have to convert it a little bit if you like. I would prefer to convert it. And I can come back and do it here in a second. Let me just, I think I only have like 3 or 4 left. Or is it just 2? Just 2? Okay, so that one's interesting. Again, this is all possible on there for sure. And then this guy, that's a yes. That's a yes on there. And that's it. Oh no, there's more. Cool. There won't be Jacobians. I don't think, no. No Jacobians, no. No, yeah, because it's not a good testable thing. I could give you two okay questions, but then you're not really learning anything or showing me nothing. Whatever, you know. Jacobians, yeah. I mean, this is like, you know, r squared, so r is equal to 3, and then we got cylindrical coordinates. Top and bottom, again. You got some r values. I can come back and do it here in a second. This is Jacobian, but this is on the quiz. This is not on the exam, for sure. So I don't want to do it right now, because that took forever. I mean, they're great. I love them, but not a good test question. So would you like me to go back to some of these other ones here and maybe do? Oh, you like 40? All right, let's do it. 40. Yeah. So now we're done with the overview. You pick questions, we do them. Happy times. Okay, not happy times. Why do you give me the hard ones? Stump the professor every time. If you stump me enough, you're gonna remove me from my job. So they say we have to convert it. Just some light things to do here. We got x is equal to r cosine theta, y is equal to r sine theta. We got tangent theta, y over x. And then finally, x squared plus y squared is r squared. Okay. So what I have here is I have x is equal to y, x is equal to 0, y is equal to 0, y is equal to 8. And you know, I'm just looking at this silly little thing. Why would I want to convert this into polar anyways?
Because they make us.
Oh, okay. Like in the real world, this is like not supposed to be polar. Okay, so x equals 0, y equals 0, y equals 8. There you go. I mean, it's great. I mean, it's clearly rectangular, you know? So, like, why are we doing this? But that's fine, that's fine. So, they said that we're going from 45 degrees to some other theta degrees. I'm going from 0 out to some formula, and then I have r times something else, blah, 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 blah. dr d theta. If I could just write a d theta, that would be nice. Yes, Jared. Close enough, close enough. Okay. So, I definitely have the required r in there. But I was also supposed to have an x. And what is x equal to is theta. Y'all picked up bad habits from me. Gosh. You're going to go on to the next class and they're going to be plus c. Anyways. So if this is my 45 degrees, and I'm going this way, where do you think I'm going to end? Perfect. Pi over 2. That's an easy one. And of course, I'm going to go from 0 out until this thing. So what would represent a flat horizontal line in polar form? It's cosecant. Very good. Yep. So y is equal to r sine theta. And I have my y is technically equal to 8. And I want to get, like, r by itself. I'd rather do that. Divide by sine. Theta. And we get 8 over sine. Or 8 cosecant. So that's going to be my thing right here. Yes. Yes, and if they don't, I will. And then I get mad at them. Is that good?
Yes, sir.
Oh, love doing it.
Calculated, you have to.
Oh, I would.
Back to the
Rectangle. Yeah. I'm not doing all that craziness. I'm getting there. I'm getting there. Yeah, so if I'm just going to integrate, I got x squared over 2. So then I got this dude here from 0 to y, plug a y in. So then I got cubed over 3. So it's y cubed over 6 from 0 to 8. And so I got 8 cubed. Ooh, watch this funniness. 8 cubed over 6. Okay. It won't?
I don't think it will.
That's why we're going to submit here in a few minutes.
Okay.
Give me another one.
I did want to do that, like,
Oh, yeah.
oh, yes.
The egg problem.
Also the one right after it, too.
Yeah.
The,
Yeah.
the cheese back one.
The cheese wedge?
Yeah. Admittedly, the eggs are
Did I go past the egg? I think I did.
the 6 is
That's my cheese wedge. There's my egg. All right. Let's do my egg. So I'm going to do something silly. I'm going to do double integral of top minus bottom. Bum, bum, bum. Da-dun-dun. Da-da-da-da-dun. Oh, I'm almost there. d theta. Cool. Yeah. Did you see what I did? Did you see it? Yeah. Did you see it? Top and bottom.
Chad.
Hey, what's up?
That R after the minus sign is supposed to be.
Oh, I was trying to be so clever. And I did not become clever. Bad Chad. Thank you.
Yes, sir.
I would have gotten it wrong. Would you have given me a partial credit? Yeah. Not for this.
That's the right idea. Going in the right direction. Dropped enough of that. That happened. And I mean, Chad, very often does a square root pop up whenever you see x squared plus y squared, and it always just comes to r, so I can see that being the EOX, the state.
But you know, what I should have done was write down all the steps to get to that point. So I was being lazy. Yeah.
I feel you're trying to tell us to do that on the exam.
I'm telling you not to skip steps. Like I did. Yeah. Okay, so mushing it all together, what I have is negative r to the 4th minus 14r squared. And then I think I have a 15. Oh, and then an r in the front. Oh, man. Yes. So this is r to the 5th. This is r cubed, and this is an r. And then dr d theta. Now, I'm looking for my radius. Like, basically, what would be the full radius at the bottom down there? Where would they be talking? Where would they be touching? I could tell you 0 to 2 pi. That's easy enough. But what's my radius? 0 to what? Maybe. I don't know. So either one of them that are touching at 0, it seems. So I'm going to set one of them equal to 0, the bottom one, and figure out what my radius would be. So yeah, you're correct. It would be 1. So 0 to 1. I think that should be good enough. We're going to verify and do it. So you just put it in the Desmos. Man, don't you want to do that so badly? We're so close though, guys. We're so close. And you'll never have to do an integral by hand again until the next class. Oh man, Diffie Q. Ooh, that's a tough one. I haven't taught that one in forever. I think linear's tough, but only up front. At some point, it kind of just it's always tough. I'm sorry, but you're doing so great. That's my That's my point. It's like the first quiz. Everyone does terrible in the first one, and then you get better. And okay. It's a time crunch thing, isn't it? It's a time. Yeah. It's almost done though. Almost done. Linear, yeah. Yes. But what I would say is that you've learned it because you've already gotten so far.
Hey, do I remember it?
Yeah, who cares?
Yeah, I mean, I needed to learn that.
Well, true. The exams, though, I try to pick easier ones, things that just more generally encompass. And you got Desmos. Crank it out. Oh, yeah. It's okay. You got this. You got this. It's positive thinking today. I don't know if that's right or not. I feel like I should start submitting some of these. Yeah, well, that's my math lab for you. So just complain to the tech people. Are y'all okay? Are y'all okay with this though? Yeah. Okay. So I'm gonna do top minus bottom again. Actually, that's kind of weird with z equals negative y. It's like they're literally mixing them up for no reason. Okay, so then if my top is a negative y, and then it's going to 0 essentially. Yeah, this is fine. We can figure this out. dr d theta. That's fine. So my y was an r sine theta. So then I got r squared sine theta essentially, negative. Dr d theta. To me, it looks like we're going from 0 to this thing right here, 5 cosine of theta. But this is where things get a little bit weird. What quadrant is that in? Say it again. It's the 4th quadrant. It's the 4th quadrant. And I know that it's rotated, but what's going on is you got x and y, and this is positive zone. We're like down here. So that's really strange. What then would I put for my theta angles? That's a good assumption. That's a good assumption. And we'll see if that works. I like that. It's a good assumption. Well, technically, but because this is a 5 cosine theta, right here my cosine is 0. Out here cosine is the maximum. So, like, basically I'm pointing down and I'm going this way with my angle, and it just so happens to start at 0 this time. But yeah, you could probably do like a negative pi over 2 to 0 if you want. There's a lot of options. I don't know. We'll see. We'll see. Okay. So then I have to integrate r cubed over 3. So 1/3, and then I got 5 cubed cosine cubed. Oh, there it is again. Everyone gets extra credit. Go ahead.
Oh wait, no, we haven't integrated yet. Okay.
Thanks, I guess. Yes. 5 times 5 times 5 is 125 all over 3. And then yes, this is my u sub stuff. U is equal to the cube, so I'm going to do basically u cubed. But then my du is a negative. So I think I should be able to do that. So then I got cosine to the 4th all over 4 from this to that. Whenever I plug in a 2 pi, cosine is at its maximum, 1. So then I got the 125 over 12. When I plug this guy in, I get a 0. So that doesn't matter. Yeah, that doesn't matter. And again, the 4th power was just, doesn't really affect anything. Okay, cool.
Yeah, the one that I started when I was working on this one was going from 3 pi over 2 to 2 pi. So I'm like, when you look at the graph, it looks like it dips down, then goes up and around. I'm like,
Well, it stops here on the x-axis. So 0.
okay.
I feel like I should submit. Should I submit at this point?
Yeah, sure.
Okay. Let's hit submit and see what we got so far. Ooh, what did I do wrong here? Okay, hold on. 8 times 8 times 8. Oh, and then they canceled one of them. I think that might work, but let me just verify. I know. I'm just silly Chad. Why do you do this to yourself?
One thing I always find funny is websites that got expanded, but it hates so much.
Fine! Fine! It's so mean. Okay, okay. I'm not gonna say that they win. Oh, look, we got that one right. That's good. We got both of those right. Cool, cool. Was there something else that I like skipped over? That was it. I just didn't do any others. So, yay! Give me some more. Now I got the answers, I can go back and look at them. Not be so scared. You got 15 minutes. Unless you want me to go do math day stuff. Oh, come on, man. This is your grade.
I know, I was thinking of trying to figure out if there's a problem or not that I got stuck on.
So, plan of attack. Is this okay if I talk about like the next week, what we're going to be doing?
Yeah, sure.
Okay, great.
I actually would like to know about this.
Yeah. Me too. So, we have, I think this is all, yeah, these are the last bits of the surface, or these integrals here, surface area things. I had already done them at some point, so I'm not scared of any of this stuff. It's actually pretty simple. Apply the formula, done. Apply the formula, done. Not a big deal. It looks crazy, but it's not. Surface integrals scare me. So there was that stuff, that UV stuff that I was supposed to teach you, but then I didn't. So I actually haven't done any of this yet. But I think what I'm going to try is just use this formula here. gonna try. There might be a RU plus RV, which is really annoying, but it won't be too bad. My Stokes, second to last one. So we're just gonna have to redo some of our previously learned formulas. Head curl was just one thing. That's a little bit more. Formula, plug it in. I'm not worried about this either. And then divergence is the easiest one. They always leave it at the easiest, so that's good. So divergence theorem, super easy. It's just triple integral. We're going to be out of there in no time, okay? So it looks like a fair amount, but I think we can get it done in about 2 days, maybe 3. Maybe. But then that's the whole week, practically. So let's just get that stuff done next week. We have to do the last lab. That'll be on Thursday. Actually, we have 15 minutes. I can show you what to do on the lab. What for it? I know, you're like, man, it's just. I am. And I know we don't have the computers. I know this was spontaneous. And I know Mason's not here is going to be mad at me. But whatever. He doesn't get mad, though. He's not a mad kind of guy. Yeah, he'd be fine. I'm on the online class. Let me go to the lecture class real quick. We're just going to talk about it. Okay, perfect. Let's just kind of, like, I don't ever have the answers, do I? Yeah, I never have answers. So I actually have a picture for this one. Isn't that so cool? The goal of what we're going to do is we're going to paint this shape with paint, like with a bucket of paint, okay? The bigger question is, how many buckets of paint do we need?
Right.
Well, paint would be semi-equivalent to surface area.
Right.
So we're looking for the surface area of this podium thingy. It's like where you walk up the ramp to the top and you can start talking to people, soapbox it and stuff. And we got the formula for it. And we're going to use Desmos. And there we go. Find the surface area. Total surface area. This is your game. This is your paint. Blah 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 blah. Talk about it. Okay. So in the end, not too bad. We have a formula area. A surface area formula though, don't we? Like that was actually the last section we were just talking about. Let me pull that up. So back to what we were seeing. I know, right? We're gonna get there. And right there, surface area. Okay. That's what we're gonna use, and we're gonna use some Desmos on this thing. I'll let y'all copy that down since I see you're copying. That's good. I'm trying to use every minute of time we have. You know what I mean? Because like next week we'll be pretty busy with the last sections. 3 sections in Cal 3 in 4 days. That doesn't make sense. We're gonna probably skip a couple questions. Maybe I'll have to cut down some homework. What do you think?
I'm not gonna lie, this last chapter we had some very long homework.
I know. But that's Cal 3. That's how it is. Okay, so we got this formula. Now, let's go back. So I know it's kind of weird looking, but what I want to do is see if I can replicate that in Desmos. And if I can at least do that, then I can start working on it. So let's go to Desmos 3D and see if I can do that. So I'm wanting a 3D shape, and I got a minus b times t times cosine of 2 pi times t, comma, a minus b times t times sine of 2 pi times t, comma, t over 2, and then I'm going to close it and say, oh, okay, thanks, okay. And I got my a and b, 20 and 5. Okay, awesome. Scroll out. There you go. So that's the ramp, basically. I know that it's kind of small looking. Let me try this. So you can see the ramp, and it is lifted up a little bit. Did you get it all? No, it's messed up. Okay, I'm gonna look at it. Do you got all the other ones though? Can you spell it without that one? Okay, I will in a second. Okay, so so we have this thing and it looks great. Now, what am I gonna do with this thing, right? Find the surface area of the top of the ramp in the cylindrical form. Okay, so don't we have a cylinder already? Like you see, we have like the cylinder itself, and then there's the ramp part. So what I'm looking for is basically, I got this. What's the surface area of the top of the cylinder? A circle. So I got pi r squared. That's easy. It's the ramp part that I'm worried about. Now, I have the ramp is some amount of width. I think it says b feet across, so it's 5 feet across around. So if I can find the surface area and then like remove the circle, perhaps. Let me show you. Let me draw it for you. This guy. Clear this out. So here's my idea. I have a circle. And then I have a ramp that's basically like going up, and it's gonna like disappear, essentially. But if I can find the surface area of this whole thing and then like remove the circle in the center, then I'll get the outside of it, I think. I don't know. We're gonna see. So how do I find that surface area of that guy? Double integral square root of fx squared fy squared 1 dy dx. But I need this in polar form, I believe, in order to do this correctly. All right. Okay. I should have looked at the lab before class. So I'm a little lost myself, okay? So y'all are just gonna hang out with me for a second, okay? I think that there's a polar form, but do I need polar or do I need it with a T? Oh, look, I have an X, don't I? But I don't have an FX. Is there an equivalent for that formula? Like the FDR stuff, right? See? Is there some other equivalent for that? Yes. I don't think I'm prepared for this lab. I'm just gonna admit it. I just wasted 2 minutes of your time. I'm sorry. The problem is that yes, we have an R, but I don't have an F. And that formula uses an F. And I can't pull up the answers right now because I'm being recorded. So, okay, that's fine. That's fine. I tried. Do y'all have any other questions, or should I just stop? Stop early. We're good. We're good. All right. So I'm gonna stop the recording. We'll do this next time. But one other thing is that yes, we have only the 4 days, but technically, if y'all want to, we can show up on finals week and review for the final. You know, you're okay with it? Okay, cool. And we can stay longer. We can come early. You know, we're more flexible. You know, because it's all unofficial. Okay, that's my plan. We'll figure it out. Thank you guys. Peace out, homies.